And we are recording. This is the Kubernetes SIG Network meeting of Thursday, May 31st, 2018. Let's get right into it, starting off with test review. Looks like last time a few people were handed out or volunteered to look into some failing tests. Do we want to just go around those and see what the status is? Yes. Okay.
Okay. Yeah, Francois. Yes, I look into the one that was failing. It is SIG CLI associated with a deployment with kubeadmin in GC. So it looks like not linked to network at all. Whatever the network, it is. No, it's not failing. It is flaking. And at first, I added to an existing issue on 1.8, but finally, I don't know, one guy over there said me, no, create another issue. So I created an issue, but there's no reply so far from SIG CLI or kubeadmin.
Yeah, we're confident that that's a CLI issue and not a network issue. Who else had tests? Let's see. Dan, you had one you were looking into.
Yeah, I'm still trying to dig into that. I mean, it looks like it's the kubeproxy upgrade and downgrade. It looks like some nodes just aren't starting the daemon set for kubeproxy, and there's a lack of log messages out of kubelet that would elucidate that. So I am continuing to look into or trying to figure out exactly why kubelet just simply doesn't seem to be starting those pods. It does get the add notification, but then it never actually begins to run them, whereas some nodes do. So still looking into it.
Cool. Tim, I think you had one. Is that the same story there with the downgrade?
I think it's the same story. I didn't have a chance to dig really deep into it. I have it up here and I see that it's still pretty darn red. I will leave it up on my screen and try to tackle it right after this meeting.
Cool. And I think Mike was looking into one. Looks like it's not due to networking problems. I don't see Mike on, but that's what the notes say.
Yeah, kudos to the people who updated the notes.
From a couple weeks ago, I said I was going to look into the failing Calico tests. We ended up garbage collecting those because they had never been passing and nobody wanted to own them. I know here at Tigera we've got a ton of tests that we run, so it didn't seem like that suite was adding a whole lot of value.
Okay.
Are there any other tests that people are investigating or think need to be investigated? Jason at Heptio says there's a kubeproxy issue. Is that a test issue or is that something?
It's not a test issue, but it's an issue related to how we're looking at trying to configure kubeproxy from kubeadm.
Okay. Just trying to think how to schedule it all because we've got a pretty tight meeting. Why don't we, does you think it'll be a quick kind of discussion?
Yeah, I just wanted to raise an issue because currently it looks like the command line arguments are being deprecated in favor of going full config. And we're looking at how can we possibly manage things like hostname overrides from kubeadm for the proxy because we're deploying it as a daemon set. So we'd really like to be able to keep host-specific command line arguments and not have those deprecated in favor of just the config.
Yeah. So who's been running with the kubeproxy config stuff here. Are they on the call?
So I think the real answer is nobody's been really running with it. I know Mike Taufin, who's doing all the kubelet work, has been giving me grief about not pushing that fast enough, hard enough. And the fact of the matter is there's just not that many people who are interested in driving it forward, and I haven't had the time personally to do so. So while they may be deprecated, I wouldn't be worried about them going anywhere for at least a few releases. I mean, at the very minimum, we would have to give them 6 months of overlap. I don't know when we deprecated them. So I wouldn't be too worried about it. Yes, I think we're going to keep the host-specific flags, just like Kubelet kept the host-specific flags, but there's order 4 or 5 of them, not order 20 of them. How you're going to specify those from a daemon set is a different question.
Yeah, I think what we're looking at is using the downward API to set it on the daemons, on the command for the pod spec.
Okay. That should continue to keep working, especially for things like hostname override, which just don't make sense as part of the overall config.
Yep. All right. I just wanted to raise that issue because I couldn't find anywhere where that work was being tracked to kind of.
Yeah. You want to sign up?
I wish. I just wanted to raise the issue, make sure that there was, that people knew about it and that it wasn't going to disappear on us so that we can go ahead and land that in kubeadm.
I think that's safe for now.
All right, great. Thanks. That's all I had.
Cool, thanks. So we've got 2 kind of demos or presentations today. Dan, you suggested we potentially swap and put corrals first.
Well, the question there was how long was each of the things going to take? And my feeling was that network service mesh, there's been a lot of discussion on it in the past, and so maybe there'd be a lot of discussion on it today. If we don't think that's the case, then maybe we can just go with the current schedule. But I'm also noticing that there's a bunch of stuff down below too. So I think I morph my question into more of a general, how should we organize this? How long will each one of these items in the schedule take?
Yeah, so my general sense personally is the one presenting the network service mesh stuff is I have rather a lot to present. I was told to expect about 30 minutes. There's a propensity, there's a certain probability of running over. So I would, if we can get the other things as small blocks out of the way first, I would actually really prefer for them to be done first. I specifically have a very strong preference for actual business, the SIG getting done first. So for example, like I see things like the long march towards core DNS approval in the agenda, and that's traditionally been short, and I think it's important. So my tendency would be to sort of suggest that we move the short and important things first, and then I'm happy to take up the end of the agenda.
Okay, let's power through them then.
So it seems to me like we should do the last 2 items from Francois and Dane first, and then cycle around maybe to Corral and then to Ed.
Yep.
Okay.
All right. So I will start. Just a heads up on status of core DNS. So thanks to Tim, now we have the KEP approved. We are in cold slush, so we need to have all the PR that are on Kubernetes in, and only one is approved, but needs a milestone label to be sure it is for this milestone. And if someone, it has to be an owner of the SIG that make the right label. So if you can look, I think Dan, Kaze, and all team, if you can just put the right label, it's all approved and to go. After we have, so Tim, I think you have the information for the image to push. Is that enough?
I'm sorry, I lost the last part of you.
You know, you sent an email for the image to push. You say you will push the image, the coordinates image, and Chris replied to you on the name.
I'm picking up a lot of background noise from someone.
Is somebody in a construction zone? Well, that's so much better. Whoever muted, thank you. Okay, so I have the action item to repush that image. And can you just Slack me the PR number that needs the milestone, and I will push it to the top of my queue?
Okay, it is, Slack, I don't know. I can put it on the chat here.
I might lose that after the meeting. If you,
okay.
You hit me on Slack or email, either one is fine.
Okay, I will email.
And I'll put it to the top of my queue. That's all I'm doing.
So, and now we are working on the documentation. So the documentation, because in kubeadmin is default, so everywhere there is a core DNS, the kubedns, there would be a part for core DNS, and this documentation for the security patch. But that is not linked to the code freeze, so that we have time to, it's in progress.
And when do you guys think we should formally deprecate kubedns? Last month or the month before that?
I think that it makes sense for them both to be out there as GA before we deprecate kubedns. So maybe 112.
Okay. I think that's fine if we announce it in 112 and plan to really EOL it by 114. 15. Yeah. 15 under the new rules. Wow, we're really planning for 1.15 already? Okay.
And
cool.
I think that's all for me.
Great. I think that means, Dane, you're up next.
Yeah, thanks. So we've been looking at some of the changes that are going to be required for full dual stack, and the changes are probably going to be pretty extensive and disruptive. But one idea that we've been kicking around is the idea of an intermediate step of supporting what could be called dual stack on the edge, where you would have IPv6 only within the cluster, and then you would have v4 to v6 translations on the edge. For example, you'd have NAT64 and DNS64 for connections to external servers, and dual stack ingress, where you'd have dual stack on the edge, and that would load balance to v6 endpoints. So that approach would be quicker and would involve a lot, probably no API changes and such, but it would be a little bit of a distraction. So I was wondering if I could just get a feel for, what kind of weighting should we put on this kind of a concept, and is there a way that we can, easy way to socialize this? I think that is there a way to do like a white paper design proposal for this, or instead of a full cap, or I don't know, does anyone have any opinions on this?
And there's a question you know the answer to already. How much, what work do you think is required to make that work within Kubernetes itself versus just documenting for users how to do it?
I think it's mostly a documentation and testing, and the only artifacts that we might have to produce are some manifests if we put NAT64 and DNS64 within a pod, and then just some how-to instructions, and then a bunch of testing.
Yeah, that's my feeling too. Do you have a sense of the demand for something like that?
That's why I was asking. I don't know how many people are going to, we're targeting 1.12 for dual stack, but that's really aggressive, I think. So I don't know if instead of waiting, if there are customers that will want to do this alternative approach, but I don't have a feel for what the demand is.
From my point of view, I don't think that would help any of our users or anybody who I've talked to directly. I've been steering a few people towards the idea of having their CNI plugins do dual stack, but just not report it.
Yep.
And that seems to be viable without any real changes from Kubernetes.
Right.
So my feeling would be, I think the best place to invest the energy would just be in getting to the real solution. Somebody
Okay.
tell me.
No, I agree with that. I think the CNI doing dual stack is a good stopgap in the meantime.
Okay, that's good input. That's all I have. Thanks. Appreciate it.
Thanks, Dan.
Okay, I think Corral, you're on, and you've got between 10 and 15 minutes.
Oh, thank you. So I have my teammates, both Luis and Abdul, on the call. So Luis, can you present the presentation actually? We have 10 minutes actually.
So hopefully most have seen that we have sent out the proposal doc for the SRIV network plugin on the mailing list. So I'm just going to give a quick couple of slides, just giving a high-level overview of that document, and then I'll just give a demo of
really heavily.
Hey, can anybody who's not speaking mute, please? We're getting some noise.
I think that's better. Can everyone see my screen okay?
Yep,
Yes.
I can see it.
Perfect.
I can see your screen, but very hard to hear.
Oh, okay. Is that any better?
Much better.
Okay, move the mic closer, it usually works. Okay, so the motivation behind doing this is, so we know that CNI works very well for a lot of networking use cases, but there's some kind of edge cases that it is not suitable or it doesn't have enough hooks in order to do what we need. So the first case is limited network availability. So our main use case for this is SRIV. So if you have your NIC which only has a limited number of VFs, CNI has no mechanism to advertise this availability, and when the VFs have been exhausted, a pod can still be scheduled on the node and it'll fail due to the limited number of VFs. So with the device plugin mechanism, we can advertise that number and make sure the Kubernetes scheduler is aware of that information. So then another important aspect we have for our use cases is NUMA awareness. So a lot of our customers have CPU pinning, for example, in their workloads as a requirement. So we want to coordinate this with the NIC that the traffic is coming through. So at the moment, there's no planned integration or alignment with NUMA with CNI, whereas there is planned integration between the device manager and CPU manager to make NUMA aware resource decisions. And then finally, we have no mechanism to manage device C groups with the CNI. So in some of our use cases, we have to use a privileged pod, which has access to all of the devices in the C groups, whereas we would like to limit this to only the device that they've been allocated. So that's kind of some of the main motivation behind creating this SRIV network device plugin. So I know there's been a couple of different proposals on this in the community. So Vikas from Red Hat and Fabian and Peter also proposed documents. So we're not proposing another different mechanism. We're kind of building and adding to the existing work. And our main goal is to create a unified story for network devices. So our SRIV network device plugin is hopefully a reference implementation for a good way to unify your story for networking with devices. So that's what we're attempting to create with this implementation. So stop me if there's any questions at any point, or I can take them at the end as well. So there's 4 components to this project. So firstly is the actual device plugin itself, which implements the device plugin API. It's responsible for discovering the SRIV capable NICs on the nodes and discovering how many VFs they have configured and advertising those back to the kubelet so they can be advertised as extended resources. It's then responsible for, at pod allocation time, storing a mapping of pod information to VF information, which then can be used by the CNI plugin. So we're proposing an extension to the device plugin API to pass additional information to the device plugins. So this information we've passed is the pod UID and the container name. So that way we can create a unique mapping for pod to VF. So then we have the CNI shim. So the CNI shim is responsible for communicating between the CNI plugin and the device plugin. So it communicates with the device plugin via gRPC. And it passes the CNI args pod name and pod namespace to the device plugin. So the device plugin can receive the pod UID from the Kubernetes API and pass back the relevant VF information to the CNI shim. The CNI shim will then delegate this information to SRIV CNI in our case, and SRIV CNI will do the actual plumbing of the VF to the pod's network namespace. We also utilize a meta plugin, in this case Multus, to provide multiple interfaces in our pod. And then finally we use the SRIV CNI to do the network plumbing. We've also aligned this proposal with the network object work that's going on in the network plumbing group, so that we've used the standard CRDs that have been created. So then finally, just the block diagram of the different components and their interactions. So we have first the SRIV device plugin discovers devices. So it discovers the SRIV NICs on your node and discovers their VFs. And as I said, it registers with kubelet, and this advertises that number of VFs via extended resources. And then on allocate call, the device plugin stores that information. Then when the CNI is called, Multus first gets the network CRD will see that the CNI shim needs to be called and will delegate to the CNI shim, which will then get the VF information from the SRIV device plugin over gRPC, and will then delegate that information to SRIV CNI, which can then configure the correct VF for the pod. So with that, I think I can hand over to Abdul if you want to ask any questions before the demo, or if you want to wait till after the demo, whichever works.
I don't mind. I'm ready for demo anyway.
Yeah, I can stop sharing, hopefully.
Okay.
Yep.
So can I ask one quick question?
Sure.
Can I ask one question? How confident are we that the device that you need to access one of these networks is always going to be the same device name? Or let me ask it a different way. Somebody somewhere has to write the number of device VFs that you need into the pod, right? So that the schedule can actually map it out. How do we know what the formal name of the device is for a given network? And how confident are we that for a given network, say Blue, that all of the devices will be of the same type? Like, what if you have an older generation? What if you have a heterogeneous cluster where you have 2 generations of InfiniBand card that are connected to the same fabric?
I think this one is like implementation detail actually, but there are provisions we can connect the device plugin to a particular pool of SRV NICs so that it can pick all the SRV VF from this particular pool. Or the second approach is like within this box we have, if you have a platform like Intel platform, we have the NICs which are specific to the particular platform, so that we know that within this box we have the Fortfill NICs or Niantic NICs. So we will all the VF which is created within this PF or similar. So it depends upon the implementation details actually. But in our current demo, we are make sure that all this we pick all those VF from the pool actually. So we're not differentiating, for the VF.
Yeah,
Go
I think
ahead.
as well, with extended resources, you can make a generic name. So in our case, we're using intel.com/SRIV. So it doesn't really matter to the user which SRIV NIC is on a node. They just request that they require SRIV. So with that way, we can kind of support a heterogeneous cluster in that the user doesn't have to specify exactly which device. They just need to specify that it's SRIV in our
That
case.
assumes then that all SRIOV devices are connected to all logical networks? connect
No,
with.
so I think in this case you have to request both your network CRD and the SRIV. So the SRIV extended resource will just trigger your device plugin, and then the actual network you want to connect to will be determined by the CRD, I believe.
Okay, I'll hold the rest of my questions for the sake of demo time.
Sure.
Yeah. Okay. So can you hear me? Yes.
Yeah,
Yeah.
we can.
Yeah. Okay. So I'll just quickly go over the YAML files that we have. So in this setup, we're using Maltis as a way of implementing additional network devices using SRIV, and Flannel is our default Kubernetes network. So this is the configuration for CNI configuration for Maltis. So we are getting additional network using the CRD. So this is the new spec for the CRD specification. And then we have this we're creating two different kind of network definition here. So here is we are defining one network, SRIB network, using VLAN, and we're using the VLAN ID 1000. So we're just naming this also VLAN 10,000. And the similar network here, this one is VLAN 2000. Then we have 4 test pod here. So here we are using, and then a new CRD spec. So we just need to define the additional network. So this will be on top of the default Kubernetes Flannel network. So we are using here additional interface with the VLAN 10,000 network. And this pod also same. And pod 3 also just it's adding to the VLAN 2000 network, and this also adding to the VLAN 2000 network. So I'll just go over now to the demo. So I'll just quickly show. So we have a NIC here. So I just highlight this one. So I created 3 VF just for the simplicity. So in this NIC we have 3 VF. So when we run the device plugin, it should say that we have 3 VF available for this node.
Get it. So we don't have to type.
So just started the device plugin. So device plugin, so it's started. So we can see that it listed three VF here. So if we go on this terminal here, we can see the node allocatable. So we can see here that it's actually saying that there's 3 VF available for this node. So we're going to deploy the workload. So you can see the pod created and this making request for the device, and it's being allocated this PCI address for this device. And we'll deploy another pod. So that's also created. So we have 3 VF. So three pods are running. So when you try to allocate another pod in there, so it should be pending. It shouldn't be able to, because the resource is not available anymore. So that we can see this pending here. So it cannot allocate any more VF in there because only 3 VF available in there. So if you look at the interfaces in the pod, so this pod has this SRI BVF with the net zero interface name, and this is the IP address it got from the IPAM information I gave. So we'll try to communicate from other pod. So you can see that it can actually reach to that other pod from here through the VF interface in there. So I think that shows the demo here. So this is just to show that we actually able to schedule pod based on the available resource we have for the SRI BBF, and just basic mechanism how the POC works. So I think there's a lot of work we can do, and a lot of improvement we can achieve from there. So we're just here to get some feedback from the community.
I assume if you do a delete, that the pending one will now have an available VF.
Yeah, sure. It will.
You don't have
take
to.
a while, but
yeah,
no,
of course.
It should. Yeah.
Okay.
Cool. So I think we're running very close to schedule. So I think I'd ask, unless there's anything super quick, that we take any more discussion or feedback to the mailing list, and then we hand over to Ed so he has time to.
Sorry, we just have to wait a little bit to see it's actually scheduling there.
I believe you. It's good. Termination can take a while.
Yeah.
We can answer questions if you have anything while you're waiting for this one.
I think the main feedback we want is this a good way to kind of cater for networks that have a limited availability, or is there some other mechanism that we should pursue? That's kind of what we're after, I think.
Tim, I remember you discussing a long time back, well, okay, that would be like a month or two, that you weren't quite happy with the way that some of the other proposals had done resource management and specifying how many resources something needed. Have you had any further discussions about that, or thoughts, or do you know of any other discussion with resource management?
I've had a couple of conversations, but I haven't been able to put the amount of energy into it that I need to really come to a conclusion with it. I'm still concerned about sort of the overall complexity of this model, though it does seem to work, and certainly not going to say anything bad about solutions that work. I'm concerned about the sort of back and forth needed between the different components, and I feel like there's got to be a better way to do it, but maybe not within the confines of what we've already built. And so I'm still sort of chewing on trying to figure out if there's a way to make these things understand each other more directly. Having an RPC interface between the plugin classes really feels like maybe not the right way to do it. This, I think, goes back to the idea of moving the CNI plugins into gRPC endpoints. It could literally be the same process. I think that would be a step in the right direction. I'm also not sure that I understand completely the cardinality issues here of what happens if I have more than one SRIOV network, what happens if I have different devices. Like I appreciate the answer. I don't think I fully understand it. So I want to go off and think about it some more and take it to the mailing list because I don't want to eat up any more time.
Cool.
Hey,
okay, thank you.
Comment really quickly. I think that is one of the limitations of the implementation today, right? Which is there is no connectivity information being conveyed from either the device plugin or the CNI for the hardware. So you basically need somewhere, that says this. I have two, physical interfaces that are otherwise identical but are connected to different networks. How are they actually different? That information isn't there today. We're assuming everything is the same. Right?
Yes, that is the thing I'm really wrestling with. Is how much do we need to support there? Like, we could go arbitrarily complicated here. Or how little can we get away with? And how do we represent that, and who's responsible for configuring that? Is it a human? Is it a discovery system? Those parts are just not clear to me yet.
Yeah, I think that's a shortcoming we need to address in this solution for sure. Yep.
Yeah, agreed.
All right, Ed, I think you've got the rest of the meeting.
Excellent. Thank you. Let me go ahead and try and share things. Okay, there we go. So let me get this presenting. By the way, if anyone wants the link while I'm talking, there's a QR code on the bottom that'll take you straight to the slides. So, I've been talking to a lot of folks about the network service mesh stuff for a while now, and one of the things I've discovered is like people are all over the place in terms of their preferred level of concreteness and abstraction. And so it seemed like a really good thing to start with use cases, because there was a very astute question asked, what problem are you trying to solve? And the answer is quite a few of them, right? We've got all these problems wandering around in networking around Kubernetes that people would like to get solved, right? So injection of physical interfaces into pods, that's something we just saw a demo on. You've got people who want to set up virtual bridge domains and VLAN bridge domains. There are general problems that people have about getting VPN gateways from wherever the Kubernetes cluster is back to something, whether it's a corporate intranet or some other thing. You've got problems around direct connect or direct interconnect, where people may have a preferred way that they would like to get out of their cloud to some network provider of some sort. You've got the problem of connecting apps to pods for things like distributed virtual bridge domains. And you've got a bazillion NFV and service function chaining use cases going on. And quite honestly, this is not an exhaustive list. It's just an example list. So if you look at, for example, hardware interfaces, you can visualize this pretty straightforward in a pretty straightforward way. You've got a bunch of hardware interfaces. You connect them to a vSwitch. You've got a pod. It connects to the vSwitch as well. And maybe you've got a hardware interface that you would like to directly inject into that pod, right? That was very much the sort of use case we were dealing with here in the previous demo. Then you've also got cases like the VPN gateway case, where I have a pod. I'd like to be able to have it phone home to some VPN concentrator for my corporate intranet or some other specialized resource that is probably outside of the cluster that I'd like to talk to. That's definitely one that people are very interested in. You've got an almost identical problem when dealing with direct connect or interconnect, or this long time ago this was being called differential egress, and it's gone by a lot of names, but the basic idea is I have some sort of magic connection via a service provider carrier that I would like to connect particular workloads to for any number of reasons. You've got the distributed bridge domain problem, where you've got a bunch of pods, which of course start out with the normal Kubernetes networking, but you'd also like to selectively connect them to various distributed bridge domains. Distributed bridge domain 0 and 1. This is often done with VXLAN for tunneling, but frankly, there are a lot of ways you can do this, mechanically speaking. You've got an analogous thing for Mac VLAN bridge domains. These pictures are going to look really similar, guys, but you just happen to be getting these interfaces out to actual VLANs on actual switches. Same general conceptual thing, though. And then the NFV guys, I won't go deep into this, but they've got a bunch of things they call traditionally virtualized network functions or network functions. When you get to the cloud native version running in containers, they take L2 and L3 packets as inputs and outputs, and they do something to those packets. And the number of somethings is really large. There are a lot of different varieties of them. And you need to get some kind of a connectivity chaining all of these together in order to do what they would like to do. And again, I'm not going to dive deep here, but this shows you some of the sorts of problems that we have. So as we try and go from these concrete use cases to a little more abstraction, what you're kind of wanting to look for is an abstract use case. Because I just ran through a bunch of things, some of which are connected, some of which aren't. But I would like to maintain that they've got something very similar in terms of the thing you're trying to do use case-wise. And there are two ways you can approach the abstraction problem here. One is you can be implementation-focused, and the other is you can be developer-focused. So an implementation-focused abstraction would sort of say, okay, what's the previous implementation these use cases have in common? Let's figure out an abstract use case to make the current environment look like whatever this lowest common denominator of the previous implementation was. The developer-focused approach was just like ask the question: what problem is the developer really trying to solve? How do we get how do we help the developer solve that problem while making their life as easy and pleasant as possible? And interestingly enough, this kind of approach typically involves allowing the developer to ignore those implementation details that you might otherwise deal with in an implementation-focused approach to abstracting the use case. And then, of course, you want to take whatever that easy path is and make that the abstract use case that you work on. Good examples here of implementation-focused versus would be all the stuff that happened with Cloud 1.0 with VMs, where we just slapped a V in front of everything. And to a large degree, Kubernetes has done a really nice job of being developer-focused. What is the developer really trying to do? How do we make it easy and pleasant for them to do that? Anybody have questions so far? All right, cool. So if we look at these problems, the problems I sort of brought up as use cases, there are sort of two ways you could approach them as well. You can look from an implementation-focused point of view and say, okay, previous implementation was interfaces, subnets, et cetera. So let's add virtual interfaces and subnets, et cetera, to Kubernetes so that you can go and connect to these virtual interfaces to virtual subnets. I would maintain that a developer-focused approach says, okay, what does the developer really want? And what the developer really wants in all of these cases is they have a pod, they need a connection that carries either L2 or L3 payloads to something functionally that does the thing that's needed when the packets are sent. And that something could be really varied. And it's typically sometimes the network, but most of the time it's actually not. So I'll run through some examples here. They may want connectivity to isolated resources that are outside of the cluster, various mechanisms of protecting them from threats. Allowing pods to talk to a particular isolated network like the radio network, load balancing to things completely divorced from their Kubernetes implementation, connection to container network network functions, connectivity to corporate internets, guaranteed latency and bandwidth. These are all functional things that developers want. Not a single one of them directly has to do with a subnet or an interface. So if you look at it, though, it gets even worse, because you actually have a Venn diagram of these things. Because what the developer is actually wanting is not a connection to a particular network. There is some Venn diagram of these functional things that they want as a service when they want to go send L2 and L3 packets for these non-Kubernetes cases. And so thinking about this as a network is sort of confusing implementation details for the underlying network service that people really want. So the network service mesh approach basically says, okay, that's good. Let's look at three main abstractions we can use to try and get there. So the first abstraction is to say, let's have a network service. We'll treat it as that logical something that does the thing needed when you send packets, right? It gives you the protection you want, the connectivity to isolated resources that outside the cluster you want, et cetera. And then all networks, and it's important to note that all networks provide a network service, but not all network services are well described as networks. This is actually a really crucial point. And you sort of saw that from the previous slide with the Venn diagram. So the second concrete concept abstract concept here is network service endpoints. These are the concrete instances of things that you want to connect to get your network service. So this could be a pod, it could be something external to the cluster. There are a lot of ways this could work out. In this presentation, I'll be talking as if they're pods. And then you've got the L2 and L3 connection, which is literally just the tube where I send and receive whatever payload it is, whether it's Ethernet frames, IP packets, MPLS frames, InfiniBand, whatever. And the way the pod sees this tube, this connection, may be a kernel interface, it may be some other mechanism, and the underlying transport that eventually gets me to my network service endpoint may or may not involve tunnels of various sorts, but there's a lot of stuff that is completely implementation detail and thus not visible or forced on the developer. Any questions so far? Cool. So let's sort of build out a concrete example. Say I want secure internet connectivity, right? So I've got a pod, I'd like it to have secure internet connectivity. So I can define a network service for this. You know, give it a name, provide a spec, you have a selector against, you know, some pod labels, and okay, and indicate there's some channel that takes a particular payload. In this case, it's an IP payload. So this has a lot of advantages over a multi-interface approach. So it talks semantically about what the developers want. It's independent of the implementation details. It allows you to shift to thinking of this dynamically rather than being pegged to, you know, various kinds of orchestration complexity that you have to do in the background to get the service you want. And it's payload agnostic. So any L2 or L3 payload works, IP, Ethernet, MPLS, InfiniBand, whatever is invented next year. So if you look at a simple implementation of this, you might have a pod that provides the, you know, the secure intranet gateway, you know, label on it. So you end up with an L2 or L3 connection to that from your pod, and that pod is connecting to your VPN concentrator to your corporate internet. This is a really simple way it might be implemented. But life seldom stays simple. And so you can imagine people wanting to do some disaggregation to make the provided service richer, because remembering our Venn diagram, people aren't really asking for a network. They're asking for a particular kind of service, which is often an overlap of many concerns. You can imagine I still have my SI gateway pod, and I still connect to it, but it may then connect to something that's doing some basic firewalling, because I don't want to burn bandwidth over the WAN to try and figure out whether or not I should be allowed to connect to something. And maybe someone in security decides they'd like intrusion detection as well to be local, so that they don't have their WAN links being clogged by any possibly compromised system. You know, and then you finally get to a VPN gateway that handles whatever magic it is your VPN concentrator speaks. And then you connect to your VPN concentrator. Now, the truth of the matter is, from the pod's point of view, this is still the same network service, secure internet connectivity. And so the pod literally, go ahead. Was there a question? Cool. So the pod literally should not be able to tell the difference between this and the simple case. So thinking about this way, you know, in the network service mesh approach has a number of advantages over a multi-interface approach. So number one, everything looks the same to the consuming pod all the time. Two, it doesn't require complex and fragile manual orchestration of all the things it takes to do this. Three, you can support dynamic L2 and L3 connections at any time, not just the startup, but any time during the pod's existence. So if I have a pod that's an app equals firewall, and I want to have many connections coming into it that carry L2 and L3 packets, I don't have to figure all that out at the time I start it. I can figure it out as I go along. And, you know, effectively, you know, this is a composition of a number of different sort of network services into one larger network service that's visible to the consuming pod. So, and you can imagine this gets even more disaggregated. You've got your gateway, firewall, IDS. Someone decides they want to introduce L4 load balancing because they want to go to a number of different, you know, potentially proxy pods. Those proxy pods may have different decisions in terms of where they would like to send your L7 traffic, which may result in going to different VPN gateways, going to different VPN concentrators. And again, this looks like a single network service to the pod that's consuming it. But who really does, you know, do we really want to force manual orchestration network by network by network at pod startup time in order to solve these problems? I would maintain that becomes an almost intractably difficult problem. So getting there. So how would the network service mesh approach look at solving this problem? So we're going to build this up progressively. We're going to start by looking at the node local case, right? So for the node local case, we just presume that whatever the network service endpoint is we are trying to reach for our network service is running as a pod on the same node. Now, if you think about this as an analog to what we do with TCP connections, we literally have nothing in existence for establishing L2 and L3 connections, if you will, that's analogous to TCP. And so we need to introduce something that does that work for us, that does the control plane behavior for that particular case. In this case, we call that the network service manager. You just run it as a daemon set on your nodes. So your network service endpoint sort of indicates that it's exposing a channel. In other words, it's open for connections of a particular type to provide a network service. When a pod decides that it wants to request a connection to that channel, it sends a gRPC request over a Unix file socket to the NSM, which then forwards that to the network service endpoint. Once it's accepted, the NSM goes and talks to whatever your data plane is, whether it's a kernel or a vSwitch, and creates an interface for this purpose, or some other kind of thing like vhost user or MIF, doesn't really matter. It injects that interface into the network service endpoint pod. It creates an interface on the other side for the pod, injects that into the pod, and cross-connects them. So at this point, you effectively have coordinated in a peer-to-peer manner what it is you want here. Now, if you're wondering, what if the pod doesn't know how to request a connection? You could always do this with init containers. So let's talk a little bit about what's being communicated as part of this negotiation from the network service endpoint to the network service manager. Because we're doing this with gRPC, and we're doing it connection by connection, we have tremendous flexibility. So we can attach metadata to the channel, labels that basically allow us to distinguish things offered. You obviously have to provide the name of the network service you're providing. And you can give a preferred ordered list of mechanisms for how you would like to get your end of the tube or connection. Kernel interfaces, vhost user, MIF, or others. And then when the NSM comes back to whatever pod is providing the network service, it can provide any sort of necessary information there before it injects it. And this is another interesting and important point. The network service can optionally, on the accept connection, provide parameters to be passed on to the requesting pod for things like addressing, routes, and all the other kinds of things that you may want to handle dynamically. So for example, in our VPN instance, if I have a VPN concentrator and I need to add prefixes that are things that should be routed to the internet, I don't have to go and deal with redoing all of my sort of fragile manual orchestration. When that happens, the VPN concentrator lets the VPN gateway pod know, and when someone connects to it, it provides those parameters as part of its response.
I have a question regarding this previous slide, the one more previous. So for each service connection, we might have interface connection, like L2, L3 connections for each service.
It's actually the simplest way to be able to tell different L2 and L3 traffic apart. It turns out you have to go through massive machinations if you only have a single tube to figure out what to do with, say, I get 3 different MAC addresses that arrive or 16 different IPs that arrive. Figuring out how to demultiplex those back out to get to the originating pods for the reverse traffic can be a really, really fiendishly complicated game if you do not have some way of segregating them. This is just a convenient way of segregating them.
Okay, so I may not be getting it right. So for each services, we might have separate connections. That's correct.
Right, for any given pod connecting to a network service endpoint.
Okay.
Connection. Or
Okay,
you could have a separate connection, yes.
Okay.
Makes sense?
So
yeah, it makes sense, yeah.
Cool.
I had another question, Ed. So in what cases were you thinking of that a pod would want to request a network service endpoint after it has started? I was just thinking that, in the past, as far as I can remember, we've sort of considered pod networking static from the start of the pod. And, it's like, are we discussing changing that at some point, since that is kind of an update to the model of, pods that are small and start quickly, and if something goes wrong, they just get restarted.
I was insufficiently clear about something. And so the insufficiently clear about something was none of this actually touches CNI or the existing Kubernetes networking. That stuff works. We don't want to break it.
Right.
What we have here is situations where events occur after the pod startup that may require the pod to be able to support different connections. So the simplest one to imagine is if I have a network service endpoint, say this network service endpoint is my VPN gateway. All of its clients are not going to be started at the time that the VPN gateway comes up. Those clients are going to come and go independent of its own life cycle. And so it's going to, you either need to handle the very complex problem of trying to bring all of those across a single connection to it, because you only could set up a single connection when it started up, which provides huge problems of orchestration. Or you need to give it the opportunity to have new connections in response to events that have occurred. In this case, clients of it's coming and going. That's certainly one example of where it's very, very convenient to have dynamic dynamicity in this situation. That answer your question?
Yeah, I think so. I'm not entirely clear on it, but I can take those replies off list or onto the list for time's sake.
That would be perfect. Thank you so much. See, we've gone through. Oh, if you're looking at sort of the negotiation between a network service endpoint to the NSM, we've talked about that. If you've got a pod that's trying to connect to a network service, when it sends a request connection, it can say things like, this is my preferred list of mechanisms I would rather use. Maybe I prefer kernel interfaces, but I could also do vhost users. It may express things like affinity preferences, like please, if possible, connect me to something on the same node. And it may also communicate device claims, like I would actually really like to get this connected to this network service via a physical interface, please. And there's a whole separate deck on how that might interact with the device plugin. And then on the response, again, with the accept connection, optionally, the NSM can pass through the parameters from the network service to the pod about things like addressing and routing and other kinds of things that are relevant. So I don't have to figure out how to peg those up statically all the time. So next step up would be doing this between nodes. This looks very, very similar to begin with. You get an exposed channel. But in this case, you advertise the network service endpoint to the API server. Just like when you get an endpoint that comes up, you may have an endpoint for services in Kubernetes. Then when someone requests a connection on a different node, their NSM can go look up network service endpoints and make a selection decision, and then communicate NSM to NSM to get the connection set up. Then again, this looks very, very similar. You get the injection of interfaces. The difference here would be we get a creation of a tunnel on the receiving end, and then when the connection is accepted on the originating end, you get injection of the interface, and you also get the creation of the other end of that tunnel.
Do you have a slide with an example of what that resource looks like?
I absolutely do. I have an entire deck that talks about doing how you might do hardware interfaces.
Sure.
Is that the
was that what goes into that network service endpoints struct?
Oh yes, I do have an example of that. I think even earlier in this deck, but I have some decks that go more into detail. But the network service and the network service endpoint. I do not actually apply for the network service endpoint, and that you're right, that needs to be done.
Okay. What kind of information in general is in there?
So in general, you would need to know things like, how do I reach an NSM that I can go talk to about getting a connection here? Because keep in mind, the NSM1 is doing the lookup for the endpoint. It has to figure out who NSM2 is that it's talking to. So that's the sort of information that you would end up storing in the network service endpoint. Just like we currently store some reachability information for endpoints, I suspect that you would wind up with a little bit richer data at a network service endpoint just because the space of possibility is a little greater.
I see. Okay.
Cool.
So for what it's worth, one of the things I appreciate about this approach is that it doesn't have to handle the existing Kubernetes networking stuff, but it could.
Mechanically speaking, it absolutely could, and it could actually let you do different flavors of the existing Kubernetes networking. So there's an interesting space of possibility there to explore, but it's explicitly trying to be in a position of being orthogonal if that's what the community decides.
So that tunneling between the two data planes, is this, if there's an existing tunneling, is this another layer on top of potentially existing tunnels, or what is that?
That's going to depend very much on how your data plane is handling that. Data planes there's a huge variety in stuff that in what people do down at the data plane level. It might be helpful to go to the next slide to get a sense of how that might end up. So Does that make sense? Let me go to the next slide.
Yep.
Two NSMs negotiating back and forth. One of them requesting a connection will communicate some information about its preferred list of mechanisms, because there are a bunch of them, and the number keeps growing depending on what your payloads are. And then when you get an accept connection, there's some indication of the selected mechanism and whatever those mechanism parameters are. So that sort of ends up being this. You could actually include, as I said, the pass-through parameters for addressing and routes and whatnot for the pod. The nice thing here is, and this sort of gets to your question, because we are writing a gRPC to do this, we can provide the necessary information to do smart things. We probably don't want to over-specify it, but we can do the necessary information there. And because we have the NSM as a control plane, and you want to be agnostic as to the data plane, the real question is how smart is your data plane, not how smart is the network service model.
Okay.
Make sense?
Yep, thanks.
The one more question. So each service could have multiple endpoints, right? Is that
oh, absolutely.
the same case? Okay.
Absolutely. And you could end up load balancing between them. Yes.
Okay.
Mm-hmm. Yes, very good question. So this is another argument I wanted to make really clearly, because I've heard this comment made a lot. The network services really do form a mesh. And when I think about a mesh, what I'm thinking of is a collection of systems that can connect directly, dynamically, non-hierarchically, and cooperatively to accomplish a task. And that it's sort of dynamically self-organizing and self-configuring. So this is sort of just pulling forward from the example I gave earlier. What you really do have is a collection of these systems being pulled together. And if you could imagine each one of these pods exposing the network service that's being requested by the other, what you effectively, I'm missing a couple connections here, apologies. What you effectively wind up with is the peer-to-peer negotiation between these as they consume each other in order to provide the overall network service that's perceived by the pod. So, quick question, does that satisfy any of the mesh detractors that I'm actually talking about a mesh?
I guess you mean me. And
you're not the only one.
I think the word brings baggage that makes it more confusing to digest.
That's a fair assessment.
Especially today with the service mesh sort of being the hot sexy, it's difficult to talk about this without people sort of saying, well, but what about Istio? What does it mean about Istio?
True.
That's neither here nor there. So on the one hand, we're over time, so we should wrap. But,
apologies.
On the one hand, it feels like it's very niche and it can sort of do its thing and not bother anybody, which is great. On the other hand, it feels like an opportunity to also possibly converge some concepts like, could we build a model for multi-network that's built through here that captures the same ideas as multi-network, and would it be any better or would it be worse?
I do have other decks where I've endeavored to actually lay out how you might go about doing this. Obviously, there's no time for that here. I did sort of want to close, as I often prefer to close on the way out, with some appreciation for folks. So, Frederick and Kyle have been furiously typing code for this. Prem Senkar and John McDowell have been working on use cases. John has also been doing some more esoteric code that may eventually come home. Mike has been great about insisting on precise expression of ideas, and this is infinitely more comprehensible as a result. Dan and Chris have been extremely encouraging, supportive, and providing good introductions. Tim and Matt were really, really patient, listening, asking questions, providing feedback and sanity. And then just generally, we have meetings going on right now weekly, and the broad community for Network Service Mesh has been great about feedback, support, and advocacy. So we would love to see you guys at that meeting. They're 8 a.m. Pacific time Friday, so we've got one tomorrow.
So what is your desired outcome at the end of all this?
So the desired outcome immediately here is to get feedback from the community, some of which you guys have provided, and get broader engagement so we can try and solve all of these problems in a way that's converged and sane, that doesn't just look like an accumulation of Band-Aids. And then, effectively, I think it behooves us to stay in connection with the SIG networking and see how we can collaborate together going forward. While we are absolutely capable of being orthogonal, that doesn't mean there aren't really good opportunities for us to do interesting things together.
Okay.
Cool.
How do we get to participate in the network service mesh community, the meeting tomorrow? Where do I find the details?
So in this deck, there's a link to the repo. If someone could drop, I'll stick the deck link in the meeting minutes. There's a QR code if you want to haul out a camera and just take a picture of it that you take you to the same place. And that's where we've got the code, the meetings, the use case docs, a bunch of the slides I keep referencing that explain other things and do more complete walkthroughs. And so if you'd like to get involved, that's how I would suggest doing it. And I'll go stick the link immediately after in the meeting minutes.
Thank you.
Cool.
I think the thing I like about this, and I know it's something that Tim has talked a lot about in the past, is that it does focus more on the developer. And that's something we always kind of wanted to get to with the multi-network approach. So thanks for thinking more about that and trying to keep pushing that forward.
Thank you. I'm glad that worked well for you. And I'm so sorry for keeping everyone so much over. I did not intend to run this over, but I'm definitely glad that I was not holding up real business by running over. That would be bad. So,
okay.
All right, cool.
All right.
Talk to you later.
Thanks, everybody. See you next time.